Good morning, students. Chapter wise MCQs, I think we have cleared. Okay, now we will see some questions, random questions from random chapter. Okay, yes, first question is energy of a charged particle is U. It is removed from battery and then connected to another uncharged capacitor having the capacitance twice the first one in parallel. Energy of first and second capacitor respectively. See, in initial condition you are given a capacitor which is charged from a battery. Okay, let capacitance of that capacitor is C, okay, voltage V, and due to this supply battery, charge on capacitor is Q. So what is energy of capacitor? Q is equal to, it is Q square upon this. Simple. In initial condition, you are given a capacitor which is connected with battery having voltage V. So let charge on this capacitor is Q, and energy U is equal to this Q square upon 2C. Now, this capacitor is then removed from battery. Yes, this capacitor is removed from battery and it is connected to another capacitor having twice its capacitance in parallel. This capacitor is removed from battery and it is connected to another capacitor having capacitance twice. Okay, so your question is, what is the energy of first and second capacitor? See, as this capacitor is connected to battery, charge is stored on it. If we remove battery and connect with uncharged capacitor, then discharging of first capacitor takes place and charging of second capacitor takes place. Okay, means simple. Charge moves from this first capacitor towards second capacitor. So in parallel, this charge will flow up to that potential becomes same. So yes, I am assuming that when potential becomes the same, charge on this first capacitor is Q1, charge on this second capacitor is Q2. Okay, so if I can find what is charge on first and second capacitor, I can easily find energy. Yes, for that you have to use law of conservation of energy actually. Yes, for that you have to use law of conservation of energy. Okay, that is total initial charge is equal to total final charge, that is Q is equal to Q1 plus Q2. Q is equal to Q1 plus Q2, equation number 1. Okay, now as they are connected in parallel, charge will flow until their potential will become same. So V1 is equal to V2. I can say Q1 upon C1 is equal to Q2 upon C2. Okay, so therefore I can write like this: Q1 upon Q2 is equal to C2, yes, it is C1 upon C2. Clear? So if I take component to a numerator, is equal to, it is C1 plus C2 divided by C2. I can write this Q1 plus Q2 as Q. So therefore Q upon Q2 is equal to, I can write C1 plus C2 divided by C2. So if you make Q2 as subject, then Q2 is equal to, it is Q C2 upon C1 plus C2. And similarly, you can write Q1 is equal to Q C1 upon C1 plus C2. So see, this portion you do not have to write every time. Okay, yes, this portion you can remember these two equations directly. Okay, whenever two capacitors they are connected in parallel, then what is charge on each capacitor after connection? So yes, you can remember, okay, Q1 is equal to QC1 upon C1 plus C2, where what is Q? Q is total initial charge. Q is total initial charge. C1, C2 capacitance of capacitors. For this particular case, I can say Q1 is equal to, it is Q. What is initial capacitance? It is C. So it is C divided by, it is C plus 2C. So obviously is equal to, it is QC upon 3C. So I can say it is Q by 3. Yes, it is Q by 3. Similarly, Q2, what is Q2? So it is Q C2 upon C plus 2C. And then is equal to, it is obviously it is 2Q by 3. Then see, we can easily find what is Q1 and Q2 after connection if you remember these equations directly. Okay, now how to find energy? So yes, U1 is equal to Q1 square upon 2C1. q1 square. Q1 square means it is q square divided by 9, and here it is 2c. Yes, here it is 2c. 2, that is from this equation, and c1 is equal to c, we know that. Now we know that q square upon 2c is equal to u, so I can say it is u by 9. So what is the energy of first capacitor after connection? Yes, it is u by 9. Yes, u2, it is q2 square upon 2c2. So is equal to, it is, what is q2? Q2, yes, here it is q2, it is 4 q square by 9. Okay, divided by 2c2. So yes, it is 2. And what is value of c2? C2, where is c2? It is 2c. It is 2c. Okay, so yes, this q square upon 2c, this q square upon 2c is called u, and this 2, here it is 2. So it is 2u by 9. It is 2u by 9. So yes, it is your answer. Okay, if you are given one capacitor is connected with battery, then it is removed, then it is connected with another capacitance. Then if you remember these two equations, okay, of q1 and q2, then this question becomes simple. Okay, yes, you can directly find the value, that's why. Okay, you do not have to write this portion actually. Okay. Now next question. See, it is from chapter number 4, that is moving charges and magnetism. A galvanometer of resistance 50 ohm. A galvanometer of resistance 50 ohm. Okay. Yes, I will write data initially. G is equal to, it is 50 ohm. Is connected to a battery of 8 volt. Yes, it is V is equal to 8 volt. With a resistance of 3950 ohm in series. A full-scale deflection of 30 division is obtained in galvanometer. In order to reduce this deflection of 15 division, the resistance in series should be, yes, the resistance in series should be, see, actually question is RS1 is equal to 3950 ohm, and due to this, and at this point, that full-scale deflection is of 30 division. Okay, RS2 is equal to question mark, so that it reduces to 15 division. Now what is meaning of this full scale deflection of 30 division? Hello, that full scale deflection actually indicates current capacity, that is nothing but Ig. Yes, that is indicating but Ig. So whenever RS1, that is 3950 ohm is connected, full scale deflection occurs at 30 division, means during that current capacity is Ig. If I want to replace or I want to reduce this deflection to 15 division, means I want to decrease its current capacity by Ig by 2. By Ig by 2. Clear? Now see, for galvanometer to convert in voltmeter, we have actually one equation. Yes, actually we have one equation, and that equation V is equal to, that equation RS is equal to, of series resistance actually, if you know. Okay, that is equal to, it is V upon Ig minus G. So from this you can write it is RS plus G into Ig is equal to V, Now for two different cases, how to write this equation? I can write this equation as RS1 plus G Ig is equal to V. Which thing will change? So this resistance and this current. Galvanometer's resistance will remain same, battery's voltage will remain same. For second, I can write it is RS2 plus G. Now current capacity is reduced to, it is Ig by 2 is equal to V. Okay, so now if we compare these two equations, yes, we can easily compare these two equations. So I can write RS1 plus G Ig is equal to RS2 plus G Ig by 2. Ig cut. Now if we calculate this, then I can write here it is 2 RS1 plus 2G is equal to RS2 plus G. Okay, so if you make RS2 a subject, then RS2 is equal to, if I write it that side, then it is 2 RS1 minus 2 RS1 minus, okay, RS1, here it is, RS1 3950 ohm into 2 minus TJ means it is 50. Now further calculation you can do easily. Clear? So it is how to solve such questions. Okay. Now we'll see the next question. What is the next question? Yes. A circle of radius A has charge density given by lambda is equal to lambda 0 cos square theta on its circumference. What will be the total charge on circle? What will be the total charge on circle? That is your question. Okay. How to find this? See here. It is circle. Radius A. Okay. You are given the charge density is given by, okay, lambda is equal to lambda 0 cos square theta. Lambda is equal to lambda 0 cos square theta. You have to find what is total charge on the circle. So first of all, I am taking small elements on this circle because lambda is not constant. If I am taking this element, if this element substance angle d theta, substance angle d theta, then what is length of element? Length of element. That length of element dl is equal to, yes, we have to find this length. It is dl. We know one relation, that is angle is equal to arc upon radius. So arc is equal to, it is angle into radius, means it is a d theta. Means it is a d theta. So yes, it is first of all length of element. So what is charge on element? Charge on element. Charge on element dq. So charge on element dq, I can say charge on element dq, I can say is equal to, it is charge on element dq is equal to, it is lambda dl. Yes, we know this relation actually. Okay, so it is lambda 0 cos square theta a d theta. Now it is the charge on element only. If we want to find charge on the whole circle, then total charge on circle q is equal to, it is integration dq. So it is integration a lambda 0 cos square theta d theta. Limit, yes, what is limit of this integration? If I am starting elements from this element, then see these elements are between 0 and pi by 2 because integration is with respect to angle. So I can say it is 0 to 2 pi. It is 0 to 2 pi. Simple. Okay. So yes, it is 0 to 2 pi a lambda 0 cos square theta d theta. Cos square theta d theta. Now here I can say a lambda 0 is constant, so it is out of integration. So q0, it is a lambda 0 constant out of integration. Cos square theta, we cannot integrate cos square theta directly, so we have to first of all convert. It is 1 plus cos 2 theta divided by 2 d theta. Limit is from 0 to 2 pi. Yes, limit is from 0 to 2 pi. Any doubt? Okay. Okay. Now how to integrate this? So is equal to half. If you want to find this integration separately, then yes, you can also find this integration separately. See here, we will solve this integration separately, so we do not have to write in details actually. Okay, sure. Here I will do that. Okay, integration cos square theta d theta. Limit is from 0 to 2 pi. Okay, so cos square theta is equal to, it is, I can write this 0 to 2 pi 1 plus cos 2 theta divided by 2 d theta. Okay, now if I separate this term 1 by 2, then what is integration of 1 by 2 d theta? It is obviously, it is 1 by 2 theta. Limit is from 0 to 2 pi. Plus, here it is. What is integration of cos 2 theta divided by 2? What is integration of cos 2 theta divided by 2? So yes, it is here actually sin 2 theta divided by this 2 and plus this 2. So it is 2. Limit is from 0 to 2 pi. Limit is from 0 to 2 pi. Any doubt? Now put limit in this equation. Okay, theta is replaced by, so it is 1 by 2 pi minus 0. And plus, see, if you put limit here, sine 2 theta means if you put theta is equal to 2 pi, then it will be sine 4 pi. We know that sine 4 pi is 0. Then you put 0, then it will be also 0, then it is 0. So this 2 cut, this 2 cut and 2 cut. So your answer will remain only pi. So what is integration of this cos square theta? It is nothing but pi. So q is equal to, it is a lambda 0 and its answer is pi. So yes, q is equal to, it is a pi lambda 0. Yes, it is a pi lambda 0. You have to remember this integration. Okay. Now there are actually 4 questions possible here only. There are actually 4 questions possible. First, a circle of radius a has charge density given by lambda is equal to lambda 0 cos square theta. Second question, lambda is equal to lambda 0 sin square theta. Third question, lambda is equal to lambda 0 cos theta. And fourth one, lambda is equal to lambda 0 sin theta. In case of cos square theta and sin square theta, in both cases you will get the same answer, that is a pi lambda 0, if it is cos square theta or sin square theta. When it is only sin theta or cos theta, okay, lambda is equal to lambda 0 cos theta, lambda is equal to lambda 0 sin theta, in both cases answer will be 0. Yep, in both cases answer will be 0. So yes, you can remember this. Okay, if cos square theta sin square theta, the answer will be same, a pi lambda 0. And if you are given cos theta and sin theta, then obviously sin charge will be 0. Because in chapter 7 we have obtained integration of sine or cos over a period is 0. Yes, integration of sine or cos over a period is 0. That's why. Clear? So yes, these 3 questions that how to solve MCQs, and I think this is it for today's lecture. Now we will see next questions in next lecture.